This is the Corrosive One from the BSOD forums and IRC. Today I wanted to get into a quick little talk about DECT. And DECT is the Digital Enhanced Cordless Telecommunications Standard. DECT is essentially what's being used on all modern handheld cordless phones. You see these in Europe as well as the United States. I believe there's a few other countries, but Europe and the US are the two main countries that have adopted the technology. Now what we use today is called DECT 6.0, and this is basically the step up from the 900 megahertz phone that used to be able to pick up with a standard scanner. Now the interesting thing about the DECT standard is that it does not enforce encryption, and of course the problem with that is that there's the possibility for interception, and the fact that it doesn't support encryption isn't even the biggest problem with the technology. The fact is the DECT standard uses what's called DSC, or the DECT standard cipher. The DECT standard cipher only uses a 35-bit analyzation vector, which is actually smaller than the IVs used for web encryption. It only uses a 64-bit encryption for voice channels. So you're only talking 35 to 64 bits of encryption. There's not a whole lot standing in between your conversations and another person, assuming they could intercept the call, to be able to decrypt it. That being said, DECT uses a 32 kilobit per second rate and uses the G726 audio codec, which I happen to have on my machine to allow decoding. In the United States, we use a frequency range of 1920 to 1930 megahertz. Calculating that out, that's roughly 1.9 gigahertz, roughly in that range. Europe uses the 1880 through 1900 megahertz, so 1.8, upper 1.8, lower 1.9 gigahertz range. The interesting thing about that is that recently it came into light that these little DVB-T USB video adapters for picking up high-def television can actually be modified to use as an SDR, which is known as software-defined radio. Long story short, software-defined radio allows you to use software rather than the hardware to decipher what's coming out of a transmission or what you're receiving. So, for example, rather than having an FM radio that can only pick up FM, this will essentially pick up everything within a specific frequency range, and you'll use software to decide whether or not it's FM or it's wideband FM or another type of transmission. Now more advanced SDRs can transmit as well, but for what we have right now we can only receive. What's interesting is this device can go through a range of roughly 65 megahertz all the way up to about 1.7 gigahertz, give or take. Now that's not quite enough to get into the DECT frequencies, but people have done hardware mods to get these to about 1.9. I've even seen the 2 gigahertz range. So it might be possible in the future to use these for receiving these transmissions. Now the interesting thing is there's actually already a piece of hardware that can do that, and what I have here is the COM On-Air PCM CIA card. Now this was made by a company known as Deutsche Anemand, and I probably mispronounced that, it is German. The amazing thing about these cards is that they were actually created to allow you to use VoIP, Voice over IP, and SIP servers to connect it with your standard DECT cordless phone. So this is back before you had things like Vonage, NetTalk, Magic Jack, some of these crappy little dongles. This allowed you to basically enjoy cheaper phone calls by using the internet and your standard DECT handset. And the way it was able to do that is this actually clones your RFPI, and your RFPI is the radio fixed part identity. It's essentially the identifier for your base station, the part that charges your phone. On the newer phones it's usually also your voicemail system. And that is essentially the MAC address, if you will, to your base station. So if you know what a MAC address is, essentially it's the physical hardware ID of that equipment. The RFPI is the MAC address, per se, to your cordless base station. And you can actually, basically, with this device, clone the base station's RFPI or MAC address, essentially. And then your handset will believe that this card's the base station, so that you could make calls, and this would just tunnel it through a VoIP server, and you'd get cheap internet calling. Not too long ago, the Osmocom group, it's, well, I'll put it in the show notes, but Osmocom essentially started creating all this great open source software for different radio transmission, interception, a lot of great projects. One of their projects is known as the DECT project. And what the DECT project is a modified driver and some additional software that will allow you to use this piece of equipment to receive, intercept, and even clone another person's base station to intercept a phone call. It's also good if you just want to get an idea. Basically, think of war driving, but with DECT phones. You could actually drive around, pop open Kismet, and it will start popping up the RFPIs of phones in your area. Now, a little bit about law. I don't know about other countries, and I'm certainly not aware, but in the United States, to receive someone else's communications without their knowledge is considered to be a crime. It's a violation of the Wiretap Act. So assuming you want to mess with this hardware, that's great and all, but be aware that you really can't intercept somebody else's communications without basically hitting a brick wall with the law. I highly recommend against it. But, you know, that's, I believe, a moral call on that person's end. But I will be more than happy to link to the software if you're interested in taking a look at this. Unfortunately, this hardware is very expensive. Because there are so few of these and the company stopped manufacturing them, you can only get these from a few people in usually Germany, but I mean you see them all around the world, and they're usually sold in euros. They go for about 350 to 380 euros. In the United States, you're talking $400 to $500 for the same piece of equipment, which is, well, I spent about $450, $480 to get this, and it was essentially just so I could demo it and see what it was capable of. Now, before I show you the demo, I did want to give you a quick look here. I actually have modified this device with an external RP SMA, and I just put a standard 2.4 gigahertz antenna on it. Now, of course, the antenna is not properly tuned for the frequency range of 1.9 gigahertz, but since I'm only receiving transmissions at such close range, I really don't concern with it much. This is more or less just to see, basically as a practice to add an antenna. If you're interested in doing antenna mods, check out a few segments back. Fox did some really great stuff involving modifying the antennas and adding antennas to USB devices, PCMCIA cards, all kinds of great stuff. Okay, so I'd like to start off with our demo here. And the first thing I'd like to explain here, and you're going to notice this as we go into our demo, is the fact that the DECT standard actually does channel hopping. And there's a good chance you'll see it hop through a few channels as we go along. Additionally, there is a downstream and an upstream. With the DECT standard, encryption is not enforced. However, it can be used at the discretion of the company or the manufacturer. In this case, my handset is encrypted with DECT, which, albeit easy to decrypt, it is encrypted nonetheless. The base station, however, does not have encryption. So the upstream, I believe it is, would be the signal coming in is not encrypted. So what I'm going to do is I'm going to call Nintendo. On the phone, you won't be able to hear anything I were to say, being the person intercepting. However, you will be able to hear everything that the Nintendo operator is saying, because the upstream, or rather the base station, is not encrypted, even though the handset is. and I'll show you as I switch using a special command from one stream to the other. You'll notice you won't be able to hear the second stream. So I'm going to go ahead and start the demo. Yeah. The first thing I want to do is go ahead and change into the directory where my software is stored. And we're going to go ahead and start this up now. I'm going to use the verb command, verbosity, so we can see the channel hopping occur. The first thing I want to do, just to give you a better idea of what we're doing here, is I'm going to do a call scan. This is going to search for active calls. Okay, we're doing a call scan. I'm going to go ahead and put this on speaker. Give it a moment as it scans through the channels. You'll notice right there it has picked up the phone, along with it's on channel 27, and we have the unique identifier for that phone. So I'm going to turn my phone off, and what I'd like to do at this point is I want to be able to let you hear what it sounds like when an intercepted call is coming in before we do the actual demo. Phone's turned on. That's the sound that you will hear when the call is first being intercepted. I believe the sound is due to the way that the decoding works. But at any rate, we're going to go ahead and do an official call, and you'll be able to listen in. There's going to be a couple seconds of lag, and you'll be able to hear this phone call being intercepted in real time. So I'm going to turn down the speakers on my computer for a moment so you can listen to the phone. We'll just give it a moment.
Thank you for calling Nintendo.
Okay, I'm going to pull the phone away from the mic and turn up the computer.
Other consumer service options you may wish to try, including automated message information that's available on the site, Nintendo's website at support.nintendo.com, and consumer service by email. Hear about our other service options. Hear about our other service options. Thank you for calling Nintendo. Thank you for calling Nintendo. You have reached us after our normal business hours. We have other consumer service options you may wish to try, including automated message information that's available on the site.
I went ahead and I used the direction command. So you can hear this phone, but you can no longer hear anything on the encrypted end. So I'm going to turn off speakerphone and I'm going to start talking into this. Hello? Hello? You'll notice that there's no lag, there's no incoming call, you can't hear anything. Now, this is being decoded in real time, so you can listen to it as it's being recorded. Even though it's being decoded, it's not being decrypted. So you're not hearing anything. There's an additional program you would run to actually decrypt the code and be able to listen into an encrypted call. At this point, we're going to go ahead and stop the software. And I hope you enjoyed the demo.